Okay guys, so today I want to start talking about solids, namely volumes of solids, okay? So we have our volumes of solids that we call prisms. Prisms are what you take where you have a base, like let's say I have a base of a rectangle, I connect it to another rectangle, and I have a rectangular solid, okay? I could have a triangle, connect it to another triangle with some height, and I have a triangular prism. Prisms can be anything. You could have a hexagon prism if you want. A little harder to draw, but again, if you connect a hexagon to another equal hexagon, you would have, kind of messy, but you would have what we call a hexagonal prism. Okay, so we're going to look at those. We're also going to look at cylinders. Cylinders, we don't call them prisms, but they kind of act like prisms because cylinders connect a circle to a circle with some height. Okay, so take a shape, connect it to another shape with some height. And again, the height doesn't necessarily have to be an up-down height. It could be a horizontal height as well. Okay, but you know you're dealing with a prism when you have the same shape happening. And like here in example number one, if we start in the packet, example number one asks us to, we just start with just finding basic volumes. So I can clearly see here I have a rectangular solid, right? So I have a rectangle connected to another rectangle with some height. Okay, so in general, when you're talking about volumes of prisms, okay, volumes of prisms we say is big B times H, but big B is not the base. Capital B is the area of the base. So if you're doing a rectangular prism, you need the area of a rectangle times a height. If it's a triangular prism, you need the area of a triangle times a height. Okay, and we're going to see that cylinders actually work the same way because the base is a circle and it's the area of a circle times a height. Okay, so again, it's just a matter of which shape do I have. So here I have a rectangular prism. Now, technically I could count the bottom and the top as the rectangle base. I could count side to side as the rectangle base. I could count front and back. It doesn't really make a difference. I am going to use the 10 and the 5 as the area of my base. So that's the area of the base rectangle, which is 10 times 5, times the height of the prism would be this 6. Okay, one thing you want to make sure before you begin all the problems, and I should have checked this before I even started, is just make sure all your dimensions are in the same units. You can't have you can't have a length in one unit and a width in another unit. That doesn't count. Okay, you got to just make sure everything is in the same units. If they're not, you're just going to have to convert them to the same units. Okay, and so this is, again, this is why when we say if you learned in 8th grade or 7th grade that the volume of a rectangular prism is length times width times height, that's what it is. It's the length and width of the rectangle times the height of the prism. So here when we multiply out, we get 300. So now that we're dealing in volume, we are doing inches times inches times inches, which is going to give us units of inches cubed, right? We measure volume in cubic units, okay? All right, the next one I can see I'm connecting a triangle to a triangle. So it's a triangular prism. So remember, I need the area of the base, which is 1/2 base times height, times the height of the prism, right? So that is the area of a triangle. That is the height of the prism. So the one thing you'll notice about this triangular base, I'm just going to draw it here. I'm given all 3 sides. But again, because it's not a right triangle, none of these sides meet at a right angle. So I actually have to find the height of this prism, okay? Of this triangle. Okay, the reason why I can find the height of this triangle is to see that the triangle is isosceles. And we know if you drop a height in an isosceles triangle, it's going to split that base into 2 equal parts, in this case 3s. So what we'll see is to find the height, I could use this little right triangle, and do we see it's 3 and then what I'm looking for and 5? That's a 3, 4, 5. So you could either do Pythagorean theorem if you don't see it, or if you see it's a 3, 4, 5, we now know that the height of the triangle is 5. So I'm going to go back here. So first I'm going to start with the area of this triangle. So the full base of the triangle is still 6. the height of the triangle is what we just found to be 4, that's fine. Remember, that's just the area of the base. We still need to bring in the height of the pyramid, which is, again, this height is on a horizontal. Technically, height doesn't have to be up, down. Height is just what connects the triangle to the triangle. So in this case, it is 8. Again, my units were all in centimeters, so I don't have to worry about a unit change. When we do this math, we get 96, and it's going to be centimeters cubed this time, okay? The number 6 asks you to find the volume of a cube. Now, a cube is whose base is a square and whose height is the same measurement as the side of the square. So for a cube, okay, so it is like a rectangular prism where it's length times width times height, but since the length, width, and the height are all the same thing, we could say length times width times height, or we could say side cubed. Okay, which is probably a little bit easier to do. So here I have 2 rad 3 cubed, okay, is what we have to do. Now, it did not say whether you had to find the volume in simplest radical form or in decimal form. So obviously decimal form is the easiest. You would just type this into your calculator. But if you did have to do it in simplest radical form, what you would want to remember is that 2 rad 3 cubed is 2 rad 3 multiplied 3 times. So let's do the math we can do, right? So do you see here, you do 2 times 2 times 2, you get 8. Rad 3 times rad 3 times rad 3 is rad 27. Okay, that is not in simplest radical form, okay? So we're just gonna break that down. Remember, rad 27 breaks down into 9 and 3. I end up with 8 times 3, rad 3. So we end up with 24 rad 3. In this case, they just called them units, so we're just gonna call them units cubed, okay? Again, if they did say decimal form, you just type that into your calculator and round it to whatever they want you to round it to, okay? All right, so number 7 is one of our word problems, okay? It says it gives you the dimensions of a moving truck, okay, in feet, feet, and feet. It gives you the dimensions of a moving box, also in feet. So again, because everything is in the same units, we don't have to worry about converting. And what they want to know is if you need 200 of these boxes, okay, how many trucks are you going to need? Okay, so a whole idea of one thing fitting inside another thing is just going to mean we're going to have to divide some volumes. Okay, so we're going to have to figure out a few volumes here. So here we could start with the volume of the truck, right? So this is just a rectangular prism. So again, it's just the length of your rectangle times the width of your rectangle times the height of the prism. It really doesn't matter which one you call which. Okay, when you multiply that out, you get 843.75, right? Again, that would be feet cubed, but we could deal with units later, okay? Now, the volume of the box, right, is just 2.5. Again, they told us it was a cubic box, so it's side cubed, right? So the volume of the box is 2.5 cubed, which we get 15.625, right? But we need 200 of these boxes. So you have a couple things you could do. You could first you kind of could change the order around of it, however you want to do it, but that's the volume of one box. So if I have 15.625, if I have 200 boxes, that means I need a total volume, right? A total volume of 3125, okay? Now, what I do know is that one truck has a volume of 843.75. So all I could do on the side here is I could take the total volume I need, 3125, divide it by the volume of one truck, and that will tell me how many trucks, I need, 0.75. Okay, so you see it says 3.7 trucks. Obviously, you can't go in somewhere and rent 3.7 trucks, right? So in order to actually fit it, do you see we're gonna have to round up no matter what. Even if this were only 3.1, I couldn't round down to 3 trucks because then I still wouldn't have enough. I wouldn't be able to fit all the boxes. So this is going to always be a round up situation, something like this. We have to round up to 4 trucks no matter what, okay? All right, the next question I want to do, number 12, okay. Number 12, again, it just takes your basic volume question, tweaks it a little bit. It tells you that you have a generator in the shape of a rectangular prism that will run for 2 hours on 1 liter of gas. And it tells you that 1 liter of gas equals 1,000 centimeters cubed. And they want to know how long will the generator run. Okay, so again, if you weren't exactly sure what to do, when they give you the conversion of a liter to a centimeter cubed, once they use those units centimeter cubed, you know it has to involve some sort of volume. Okay, so the first thing we do is find the volume of the generator, right? Which is, again, just a rectangular, so it's 15 times 20 times 10, and that will give me a volume of 3,000 centimeters cubed, right? Okay, so we know we have 3,000 centimeters, right? Cubed. Well, if we want to convert that to liters, this is an easy conversion, okay? So this converts to 3 liters, right? So I know it's going to hold 3,000 centimeters cubed will hold 3 liters of gas. And if they said you get 2 hours for 1 liter of gas, all you have to do is just take your 3, multiply it by 2 to get 6 hours of running here. Okay, so sometimes they just take the question and you have to do a volume and then maybe a little bit more. Sometimes you have to like multiply, sometimes you have to divide, but there's always just like a little bit more that sometimes needs to be done, okay? Like in 15. In 15, they tell you you have a fish tank. Okay, now in this one, they give you the 2 of the dimensions, then they give it to you, they're both in inches. It's 24 inches by 72 inches, but you're missing the height, okay? Well, if you're missing one of your dimensions, it would mean you would have to know the volume. Okay, now they straight up don't give me the volume, okay? What they tell us is that one fish needs 6480 inches cubed. Now again, look at the unit. So they're giving you the volume per fish. And then they're telling you that 8 fish need to fit in this tank. So we do know the volume of the tank when we take our 8 fish and multiply it by 6480, which is the volume per fish. So when you do that, you get 51,840. Okay, so now I know I need 51,840 total volume to house my fish, okay? So now if I took now remember, my volume formula is length times width times height. So in this case, I have the volume, I have the length, I have the width, the height is what I'm looking for. Call it H, call it X, call it whatever. All you're gonna have to do is just solve this equation. So you're just gonna have to divide. Okay, so again, if you want, you could divide by the 72 and the 24 separately. You can multiply these and divide. If you want, you could use, I would always recommend, you could use N over D. Okay, so if you go to alpha y equals N over D, you could also type it in as 51,840 divided by 72 times 24 if you don't even feel like doing it. But make sure if you do it like that, you use N over D, you don't use the divide symbol because it won't work if you do the divide symbol. So it turns out the height we need is 30 inches. Okay, now number 17 tells us we have a box in the shape of a cube with a volume of 64 inches cubed. Now they just want the length of each side, okay? So again, keep in mind it's a cube. So what we do know is that all these sides are X, the length, the width, and the height, right? So remember, the volume of a cube is side cubed. We know the volume, we're looking for the side. Okay, so when we have squared, to get rid of squaring, we square root. To get rid of cubing, we cube root. Okay, so let's talk about that. So cube where that is on your calculator. So I have to cube root each side of this equation, right? Okay, so if you don't know, there's 2 places you could get cube root. If you go under the math menu, it's right there. Do you see it's number 4? That's probably the easiest way to get it. And that's, so you'll see the little 3 there. The cube root of 64 is 4. And again, the reason why the cube root of 64 is 4 is because 4 times 4 times 4 is 64. And these would just be inches, okay? Which is, again, all units the same in these problems. Okay, now the last one I want to do is kind of, I tried to draw it. I apologize for my not so great drawing. This is almost like before last week when we did composite area, when you had a bunch of different shapes, okay, put together. This is almost like a composite volume, okay? So they give you these steps, okay? So with this one, do you see this is not obviously something it is a prism, but this base right here, this steppy little base isn't something we have a formula for. So what we're gonna do is we're just gonna cut this up. You could either cut it vertically or you could cut it horizontally. But do you see if I cut it horizontally, I'm gonna go horizontal just because that's how I see it. So what I end up with here are 3 rectangular solids, right? This one on the top, this one on the bottom, this one in the middle, and this one on the bottom. So we have to do 3 different volumes, okay? So if I start with the one on top, so the one on top, I know the steps. All the steps are an even width, so I know this step is 10. I know the length of the step is 36 from down here, and I know the height of each step is 6. So this 6 comes down on all 3 of them. This 10, again, juts out on all of these. All of the jut outs are 10, okay? So I know my top step is 10 by 36 by 6. So that's one of my volumes, right? Okay, my next volume is the middle step. Now the middle step, do you see, is this 10 that juts out plus the original 10. So it's almost the same. It's just 20 times 36 times 6. And then the final volume, again, we jut out again another 10. So now I have 30 by 36 times 6. Okay, and all we have to do is just add those volumes up here and we get 12,960 inches cubed, right? Because everything was in inches, okay? Now, what they did on what the next one was, is they actually asked us in the part B, so this was for the part A, they said to convert that unit to cubic yards. Okay, so we're in inches cubed. They want to convert it to yards cubed. Okay, so there's 2 ways we convert. If we want yards, if they had just asked us from the beginning for yards cubed, the best way to do it is actually to convert all the original units to yards. Okay, so we can do that. We can go back and we can convert all of these units to yards and then find the volume again, each of the 3 volumes separately. Okay, but in terms of yards. That's a little bit of work, and seeing as we already found it in inches, there's another way to convert. Now, here's the thing I want you to be careful of, okay? So when converting, right? So we know 1 yard is equal to 36 inches. I think you would know that, right? Or maybe you know 1 yard is 3 feet, and then 3 feet should be, because 1 foot is 12 inches, 3 feet is 36 inches. Okay, and here's the thing. So you would just think, all right, I just got to take this and divide it by 36. That is not the case, because this is 1 yard is equal to 1 inch. Once we start dealing in units that are inches cubed or inches squared, the conversion is actually different. It's not the same conversion. 1 inch cubed is not, 1 yard cubed is not 36 inches cubed. Once you cube the units, you actually have to cube the numbers. So here's what I mean. So if I needed, let's just go to square units for a second. So if I wanted 1 yard squared, okay? So 1 yard squared is really squaring the 1, right? 1 squared is just 1. 1 yard squared does not equal 36 inches squared. What it equals is 36 squared inches squared. So when you square the conversion, you get 1296. So I have 1296 inches squared. If I want 1 yard cubed, I have to go back to that 36 and do 36 cubed to figure out what the conversion is. So that's 46656 inches cubed. So if you want to convert cubic inches, you have to cube the conversion. So start with your original conversion and cube everything. Okay, so what that would mean, just as a side note, okay, so as a side note, like let's say you were converting 1 foot. So let's say you needed to convert 1 foot cubed to inches cubed. So you start with the basic, right? So 1 foot is 12 inches. So if I want to know what 1 foot cubed is, I have to cube the 12. And I would get 1728 inches cubed. Okay? So this would only be the case if you converted after you found the volume. If you needed the volume in yards and you convert these original units to yards before you start, then you won't have to do any after conversion, okay? So this is the conversion we need right here, okay? So all I'm gonna do is go back and I am gonna convert this, my 12,960, divide it by 46656 to figure out how many inches cubed that is, and you get 0.28. And now you would be in yards cubed. Another helpful thing, guys, is sometimes with the conversions, I think some people get a little, they're like not sure if you're supposed to multiply the two things or divide the two things, or whether you're which way you're supposed to divide. If you're not sure about a conversion ever, the one thing you could always do is make a proportion, okay? So when you make a proportion, you would take your conversion, 1 yard cube equals 46656 inches cubed, and set up the proportion with what you want to convert. Do you see what we want to convert are in inches cubed? So that has to come down here. So inches cubed are lined up with inches cubed. And then just cross multiply and solve. You'll still get the same thing. Okay? All right, the next thing I want to do, okay, so moving on to page 21, where we get to cylinders, okay? So cylinders kind of work like prisms, where the base is a circle. Now, the area of a circle is pi r squared, right? We should know that the area of a circle is pi r squared. To make it a volume, you have to multiply it by the height of the prism. So that's always the volume of a cylinder, pi r squared times the height. So the base of the area of the circle times the height of the cylinder, okay? So here, this is a basic conversion, is number 3. The only thing that's not basic about it is that they gave you the diameter, not the radius. So make sure you use 5 here instead of 10. And then the height is 20. Again, also check to make sure all your units are in the same thing. Okay, now sometimes with cylinders, they either are going to ask you for your answer in terms of pi, okay, or in terms of a decimal, okay? So in terms of pi means this, okay? Forget the pi is even there, just do all of the number math, which would be 5 squared times 20, which is 500, and then just bring down your pi. Okay, so here the units would be centimeters cubed. If they want it as a decimal, fine, that's the easier one. So this is the part A. If they want it as a decimal, just type it into your calculator. Keep in mind the pi button here is second caret. So we have pi 5 squared times 20. And then just round that to whatever. In this case, they said the nearest hundredth. So this was 1570.80. Still centimeters cubed. Okay? So volume of a circle times the height of the cylinder. Okay? So some variations on that question can be like number 6. Okay? So where you're missing a dimension. Okay? So in this case, we're missing the radius, we have the height, and we have the volume. So notice your height is in inches, your volume is in inches cubed. We have consistent units, okay? So remember, keeping in mind the formula is pi r squared times height. This time we have the volume, okay? We're looking for the radius, and we have the height, okay? So to solve for the radius, the first thing we're going to have to do is divide by 8 and divide by pi. You can divide by both of them at the same time as long as you use alpha y equals, okay? So you can do 1,000 over 8 pi, okay? If you do, notice if you do 1,000 divided by 8 pi, you get a different answer. Then the reason why you're getting a different answer is because your calculator is following order of operations. So it's dividing by 8 and then multiplying that answer by pi. That's not what we want. We want this answer, right? So here I get 392.699. Remember, over round a little bit. Now, just like before, I have radius squared. I only want the radius. So all we're going to have to do is square root both sides. So I am going to square root. I'm going to go back up and grab that, square root that. And I get, and again, they want this to the nearest 10th. Okay, so I grabbed the wrong one. Sorry. Second square root, I want that one. Okay, and so to the nearest 10th is 6.3. Okay, so yeah, so this, I put the wrong one in. Sorry, this was the square root of 39.788. Blah, blah, blah. Okay, so here I get 6.3. And this would be inches because everything was in inches. Okay. So same kind of thing happening with number 8. Number 8, they give you the diameter of the tank is 12. So remember, we want to just cut that in half and make sure we're using the 6. Okay. What they don't give us the volume of the tank. What they give us is the tank is 30 gallons, but that 1 gallon is 21 inches cubed. So again, the fact that they're using inches cubed means I do have, that is a volume conversion. So all I have to first figure out is the volume, which is going to be 30 times 231, so that we get 6930. Okay, so I need the volume of the cylinder to be 6930. So just like before, I have 6930 equals pi. This time I have the radius, and I'm just looking for the height. Okay, oops, sorry, squared. Okay, so same thing, if you want to divide both sides by 36 pi, remember, make sure you're using n over d on your calculator. Okay, so when you do that, when you do n over d, you get the height is 61.27. Okay, they did want it. They actually didn't tell you on this one what to round to, so I just did it to the 100th. Okay, if they don't tell you, you could just leave it in terms of pi also. Okay. All right, then the last one I would like to do is number 14. Number 14, do you see it gives you this, just this little wedge of a cylinder, but they said they took out a 90-degree wedge. 90 degrees is nice because we can figure out what that is. So do you see that this really just represents 3/4 of a cylinder? So if I need to figure out the volume of this, I just have to do 3/4 of pi r squared times h, right? That's what I'm going to need to do. So whatever proportion this represents is what you're going to do. Now, if you're looking at this, one thing that should be really jumping out at you is, do you see the radius is in inches, but the height is in feet, okay? So you are going to have to convert. Okay, and again, if they don't tell you what unit they want the volume in, it technically doesn't matter. You can convert everything to inches or everything to feet. It's always easier to convert down to the smaller unit if you have a choice. So I want to keep the inches, I want to lose the feet. 2 feet is an easy conversion. That is going to be 24 inches. Okay, so that's it. Once we're in the same unit, we don't have to worry about anything else. Okay, so all I'm going to do is type in my radius, which is 9, put in my height, which is 24, type that bad boy. Again, they don't really say what they want it in, so I guess, you know what, when they don't say what they want on this one, I'm going to leave it in terms of pi. Okay, so again, in terms of pi means forget the pi, do all the other math. Do 3/4 times 9 squared times 24, and you should get 1458. And then just drop down your pi, and now we could say the units are inches cubed. Okay, if they wanted the volume in feet cubed, all I would have done is converted the 9 inches to feet right before I started the problem. Okay, so that is it. That is prisms and cylinders. Okay.